Hello guys, thanks for watching my video. Today we are going to see the fifth identities of dilogarithm. Okay, then is the fifth property or the fifth identities is allied 2 of x plus allied 2 of 1 over x is nothing but negative pi square over 6 minus half of natural log square of negative x. Okay, natural log square negative x. Okay, now we are trying to prove this one. Okay, now by integral definition of dilogarithm, we have allied 2 of x is minus integral from 0 to x log of 1 minus u by u du, right? This is we have already done in the previous. Now allied 2 of x, so I'm going to split this one. I'm going to split 0 to x is I'm going to split 0 to x as 0 to 1 and 1 to x. Okay, now you don't mind. So allied 2 of x is because negative is there because of this. Okay, both must be there. So integral from 0 to x is same as 0 to 1 to 1 to x, right? Just the same thing. Log 1 minus u upon u du minus integral from 1 to x log 1 minus u by u du. Okay, now since the integral from 0 to 1 log of 1 minus u by u du is negative zeta of 2, then is negative pi square over 6, then is we have evaluated already, right? Therefore allied 2 of x is there is negative here, so there is negative here, so it will be positive, right? So it will be pi square over 6 minus integral from 1 to x log 1 minus u upon u du. Okay, now let's use we are going to substitute u equal to 1 over t. Du is negative 1 over t square dt, right? I hope you are clear. Differentiate both sides. So allied 2 of x is pi square over 6 minus the integral from when u is equal to 1, so t is just 1, right? And when u is x, so t will be 1 over x. Okay, the upper and lower limit. So log of 1 minus u is nothing but 1 over t, right? U is 1 over t. Du is negative 1 over t square dt. Okay, because this negative and this negative become positive. Okay, allied 2 of x is pi square over 6 plus integral from 1 to 1 over x log of, so simplify this, you will get 1 minus t by negative t, right? Upon, so this t and 1 t will get cancelled, so you will get t will be there again dt. Okay, now using that, log of a by b is log a minus log b. Okay, allied 2 of x is pi square over 6 plus the integral from 1 to 1 over x log of 1 minus t by t dt minus, okay, this minus and this plus become minus, so minus integral from 1 to 1 over x log of negative t upon t dt. Okay, this is pi. Okay, so, now let's see in the next. Okay, if you see this integral, this is not there. Okay, now from 1 to 1 over x I'm going to split again. Okay, this one I'm going to trying to get this 0 to this one. Okay, 0 to something, this upper limit. Okay, now let's see in the next page this one. Okay, allied 2 of x is pi square over 6 plus, so 1 to 1 over x. Okay, 1 to 1 over x is same as 0 to 1 over x is same as just like this. 1 to 1 over x is same as 1 to 0 plus 0 to 1 over x. Okay, so this one, this is 0 to 1 over x is already here. 0 to 1 over x log 1 minus t upon t dt, and this one is 1 to 0, here is positive, right? This is positive, so I'm trying to interchange this upper and lower limit, so there will be negative 1 will be there, right? So negative integral from 0 to 1 log 1 minus t upon t dt minus, this is the same thing, keep it here, Integral from 1 to 1 over x log 1 negative t upon t dt. Okay. Now, so li2 of x is equal to pi square over 6 minus, so this is, if you see it here, okay, compare them. Integral from 0 to 1 over x, 1 log of 1 minus t upon t. This is the variables you can change, okay. So 0 to x, so here is 0 to 1 over x, that means this will be, here is negative 1 will be there, so in is positive, so it will be negative li2 of 1 over x, right? So negative li2 of 1 over x. I hope that is clear, okay. This one and this one, compare these two, okay. Now plus, this is just nothing but we have already evaluated negative pi square over 6, right? So because of negative, so this should be positive. Positive pi square over 6 minus integral from 1 to 1 over x log negative t upon dt. Log negative t upon t dt. Okay. Now putting log negative t equal to y here, only here, okay. So you will get 1 over t dt is differentiate it, okay. If you differentiate this one, differentiation of log is 1 over negative t, okay. And differentiate this one again, so it will be negative 1, so these two will get cancelled, right? So therefore 1 over t dt is dy. Okay, now li2 of x, this one transfer on the left hand side, plus li2 of 1 over x is these two, simplify, okay. Pi square over 6, pi square over 6, that means pi square over 3, right? Minus integral of, so we just substitute here, right? So when in this one, so it will be log of negative 1, okay. When in this 1 over x, it will be log of negative 1 over x, yeah. And log of negative t is y, right? So y, and dt by t is dy, okay, yeah. So li2 of x plus li2 of 1 over x is equal to pi square over 3 minus integration of y is y square by 2, right? From log negative 1 to log negative 1 over x. So li2 of x plus li2 of 1 over x is pi square over 3 minus, so putting here minus 1 by 2 log square negative 1 over x, okay. So minus, and according to the definition of fundamental theorem of integral calculus, there will be negative again, right? So that negative and this will be positive, 1 over 2 log square of negative 1, okay. li2 of x plus li2 of 1 over x is pi square over 3 minus 1 by 2 ln square of negative x, okay. This one, I hope you can simplify this. Is log of 1 over x is same as log of x negative 1, right? So there will be negative log x, okay. That's it. So it will be negative 1 over 2 log square, here's negative is there, so it will be negative, okay. And 1 over x you can simplify here, so it will be negative log x. So negative log x, right? Because of this is square, so it will be positive again. I mean doesn't change, okay. Negative x plus 1 by 2. Now using Euler identity, okay. Then is e to the pi I is nothing but negative 1, right? This is the most beautiful equation because in this it represents the constant pi, the constant e, and imaginary number I, and real number negative 1, right? So that's why they call it beautiful equation, okay. In place of negative 1, so I'm going to substitute e to the pi I, okay. E to the pi I. So li2 of x plus li2 of 1 over x is pi square over 3 minus half ln square of negative x plus half. So you can simplify again this one. So you get pi I whole square, right? Pi I whole square. How to simplify is that, so this one log square of e to the pi I is same as log of e to the pi I whole square, okay. And this is natural log, right? This is basis and this is e again, therefore these two you will get cancelled, then you get pi I square, right? Pi I square. So li2 of x plus li2 of 1 over x is pi square over 3 minus half ln square of negative x minus, right, I square is negative 1, right, so it will be minus this pi square over 2. So therefore li2 of x plus li2 of 1 over x is, so these two simplified, okay, then you'll get negative pi square over 6 minus half ln square of negative x. So this is the fifth identity, okay, of dilogarithm, okay. So that is the proof. I hope you are clear with my explanation.